Good evening all, welcome to another C64 coding. Now this week, well earlier this week I should say, I found a book, going through all my old books and whatnot, and I found this little gem. And we're going to do some of the programs in this. Now this is a cool book. It's as old as me, quite literally printed it in the same year. It's not in the best of conditions, I'd admit, but it was written by these two strapping young lads, a Timothy or Knight and Darren Labatt. Now, really, it's from Indianapolis. Sweet. I think this book was brought by my mother when we first got our first Commodore 64, but my brothers didn't really take to it. Yep, okay, copyright 1983 and first edition, second printing 1984, so it's old as me. Alright. This work is dedicated to Mr. Donald A. Black, whose insistence on our working and thinking like good writers made this book possible. To him we are forever grateful. That's nice. So chapter 1, introduction to programs, blah blah blah, how to use it, we already done that. Already know how to do that. Graphics of the Commodore. So jumping right into it, we're going to do a program here called Micro Sketch. It's not that long, doesn't have that many lines, as you can see. Just there, it doesn't have that many lines. But what it does, essentially allows us to sketch with the arrow keys. It's just basically a rudimentary drawing program. So in this simple low resolution graphics program that allows you to move the cursor around the screen using Y, B, G and H. Okay, so center of the keyboard, alright. Keys for up, down, left, right movements respectively. See this thing? As you move the cursor on the screen, a trail will be left against the black background, which allows you to draw any shape you desire on the screen. Then it explains the lines of it. So what we will do is we'll type out this program, then we'll work our way through the important bits as it says here. So let's get to it, shall we? So, it's been a while. Sorry it's been so long since I actually did some coding videos, and I actually went off and did some other things. Terribly sorry about all that. I know a lot of you subscribe solely because of my coding videos. I do apologize, and I'm just trying to Arnold. Okay, I'm going to have to put my mic up a little bit. Sorry, this might get a little bit noisy. Alright, I think we are good. So, no, that's not going to work. I'll just have to put you here then, won't I? Okay, so let's start off. 5 S. Whoops, wrong window. This window. S equals 5 S equals 53248. 53248, which is the start of the VIC chip, because we're doing graphic stuff. So we need the VIC address. Poke S plus. Oh, that's right. What the? Why didn't you go down? Okay. Alright, good. We're there. Alright. S. Poke. S. Shift plus. I have to remember the numpad doesn't work in the Vice emulator. In case that's what you're wondering what I use. So what this does... well, the next few lines are just remarks saying, yeah, low resolution microsketch by Tim Knight. Clear the screen. We're going to ignore all those remarks and just go straight on to line 40. And go print, which I think was shift. Yes, I was right. Aha. That will clear the screen for us. So the next line is another remark saying establish location, but we're not going to type that out. Go 60 L. Now if you do ever get confused at any point of me doing this, please go back and watch my other videos that I have done on basic coding where I went through the actual manual for the machine. Seems to be pretty popular, I have to admit. 9, 6. Next. 67. Okay. Go to... Hang on a minute. Oh, okay. So it goes to... I see. So basically from here, we're going to a point to initialize itself, to get to the initial point where the cursor is. 150. Okay, let me go back here. So this is the start of our infinite loop. Pretty much of any program, you just basically doing an infinite loop if you need require constant input. Get a shift star. Get a. Oh, so it's get input. I see. If a star $$ equals an empty string, so i.e. nothing, then 70. So basically saying get the keyboard input. If the keyboard input is empty, then just go back again. So basically start over. So, but if our keyboard input isn't, so next time we'll go if it isn't, if a string, basically the $ means it's going to be a string or a series of characters, is what I meant to say. If y, the formatting in this code is absolutely horrendous. L is greater than 55335, and then so basically if the screen RAM, if the cursor location, which is what L is, the top here, so L is the location of cursor in color memory. So if it's greater than the bounds, it's greater than the left-hand bounds by the looks of it, of the screen, which is, so you have to remember everything in BASIC, everything on the Commodore 64 is RAM based. It has to, you got to go by your memory locations, and the screen memory starts at, I believe, at 55335. Okay. Or was it 55296? Not exactly sure. But anyway, that's the memory location that we need. So 40. Jesus, this guy's piling a whole heap of stuff on one line, which is generally these days a rule of thumb you don't do. Try to break it up as much as you can. But since it's a single line if it was a single line if, so basically if you, these columns, these things mean treat the next bit as a new instruction but on the same memory location, same line in the program, 80. But if you did that in an actual program, you'll get a lot of people actually yelling at you. Trust me on this. I was a coder for the Blender people. I was a Blender coder. My God, can they be... Oh my God, can they be very pedantic about your code. Not like that's a bad thing. A good coder always... good coder always make sure his code is readable, is logically laid out. Did I do the wrong one? No, I didn't. No, I didn't the right one. Okay. Oh, is so many lines here that look similar. 5, 6, 2, 5, 6. 5, 6, 2, 5, 6. Excuse me. Alright. So we're going up forward. We'll work this out as soon as I've finished typing it out. This is getting a little bit weird. But yes, a good coder always makes sure his code is good. I think I've made a boo-boo. Yeah, there was a misprint by the looks of it. But we'll see. L equals L plus 40. Basically, really, if you want to get into coding and you have a semi-basic knowledge of it, dive into an open source project like Blender or Linux kernel or GIMP or Critter or something like that, because then you learn real life skills on how to actually work on a project. Now, sometimes open source projects get a bad rap for being hard to get into, or people are not very supportive of new coders or something like that. Nah, that's just not true. Most of the projects developers I've looked at and I've worked with and talked to are actually really nice people. 2, 9, 6. Then L equals L minus 1. Oh, that's right, because it's a 40 column screen, so you minus 40, you're getting up one row. How stupid am I? And then go to 150. So basically 150 in this case, line 150 is the actual drawing to the screen, and I just mucked that up, didn't I? I did. Oh, crap. God damn it. L is, what's that? 100. L is greater than 5, 2, 9, 6. So yeah, basically right now I am indebted to the free open source community, especially Blender, because without Blender I would not have learned to code the way I'd have. It's kind of weird saying that. Some people don't believe me how much of an impact Blender's actually had on my life, but it's had a huge one, because without it I wouldn't have even had a job. First job I have, well, the reason why I moved to where I am is because of an animation job. I was an animator for a while. Granted, I didn't use Blender at work because we were using Max at the time, but because of my demonstrable skills in Blender, honed a lot by the coding of Blender, because I knew how the code works, so I could exploit it a lot more, and had a huge interest in CG work, CG technology. I was snapped up, and I was an animator. Then animation work dried up. I became a programmer once more. That is what I'm doing to this day. So here we are. Next line is a remark, essentially a comment. Poke in white character. So we don't need to do that. So here we are, finally at line 150, where all these things are pointing to. So we've got poke L1, basically pointing a 1 into the memory location of L. And then we're going to poke into, I don't think it's in the color location, I think it's in character memory, I think this next bit is. So poke L minus 54272 and now we'll poke it into the character memory. So poked a color white into the color memory, then we poke a character into it. So say I want a white character, and the second bit is actual character. So did I put poke in there twice? Why did I put poke in there twice? So basically this bit here, we set the character color and then set a character. And by looking at this image, it looks like a checkerboard pattern or sort. But anyway, let's go next. Next line, 160. Let's start all over again. Go to 70. So there we go. So let's list this all out. See what we get. Okay. Why is poke S plus SS? Should be 3-3. Whoops. So, okay, 7. Poke plus S plus 33, 0. So list it again. There we go. All right. So we've got it all in here. So basically, let's have a look at. Hold on a sec. I'll just bring me back up for a second. I know you all just wanted to look at my lovely, lovely face. Here we go. Okay. So, I'm just going to show you what this book has. So basically, at the start of it, it says, explanation of the lines within the program, and then over here it goes through all the important variables and what lines do. So I'm just going to read through all that, if that's okay with you lot, just to make sure we're all on the same page. So, okay, so basically what this says, since we've got this up and running, 1 to 40. So basically these 3 lines here. Specify VIC chip starting point, blackout, and clear the screen. So basically this puts black in the background, which is 33, which is 33. So the memory address is that plus 33 for the background. Fair enough. 50 to 67. So basically from here to here. So these 2 lines. Hang on, yep, these 2 lines. Establish location of cursor and jump to line 150 to display location of cursor. So next one. From 70 to 110, basically from here to here, these big if statements. Get keyboard input and change location of cursor accordingly. 120 to 160, which is basically these. Put white character in cursor's trail and go back to line blah blah 70. Important variables in program. S, which is the start of the VIC chip. L, location of the cursor, which is defined here. A is the keyboard input. Yeah, we already worked that. Special note. The VIC chip is simply the graphics chip that controls most of the functions to modify the video screen. In this case, it is used to fill the screen with black. Sample run of the program, suggested changes and projects. Try making a high resolution version of this program. See if you can make other user definable features to this program, such as definable cursor color and background color. Wow. We could do that, but let's run it. Let's see what we get when we run this, shall we? Put my book back down. Let's take a sip of the gravy. Because I know this is not going to work, but let's try it anyway. Okay, it didn't. It did work. Oh, okay. It does work. Hey, well, hubby, it actually works. That's cool. Oops, where am I? There. I can't really see where my cursor is, but that is cool. That actually works. I'll be a bear monkey's asshole. That is cool. So what can we do? Alright. List. Okay, let's have a look. So, okay, that's white. Let's put in a different color, shall we? And I do have my manual here. Okay, so let's have a look at the manual here. Here we are. Ooh. Hold on, I'll just have a look around. Just need me for a tick. I just picked up the manual that I've been using all the time, and here, what did I land on? The actual screen memory map and the colors. So that's cool, and I think that's the color memory map. So here we are. Color. So I write to these addresses. Whoop, this side. Write to these addresses acrossways. So it starts there and works its way all the way down here. So that's cool. So we can work this out very much. Okay, so screen memory map. So that's just to change the color. And then we have this one. Shows a list of memory location control and placement of characters on the screen, which locations are used to change individual blah blah blah. Okay, but what I want is all of this here. This is the character map. Keyboard and character map, and there's one on the other side. I'm pretty sure there's one more page of this. Oh no, I was wrong. I think we are in the wrong one. Screen display codes, abbreviations for basic keywords, blah blah blah. I see. So yeah, and then we've got some more here. So let's see what we can do with all this, shall we? So I don't think that's it. I think one we want. So 102. 102 says that. What's on the other side? It's in this other one. Ah, yep, got the right. Okay, this is the right one. As you can see, where is it? See, poke value 102 is giving us this stripy, speckled one. Okay, so we poke in that one. So let's see, what other characters shall we do? That would be cool to do. Let's make it all love hearts, shall we? Yeah, so let's put 83 in there. So, okay, whoop, wrong window. I need to go over here. So this line down here, let's change this value and this value. This value here, we will change this to say 8. See what we get. And then this one over here, this value, we want to change this to 83. Okay, so let's run that. Aha! Very cool. So now we're painting with hearts. Not exactly, yeah. I do, yeah, working. That is cool. Very good. So let's see. Let's look up. How do we do random? I want to do a random values. Random. I know this one has random in it. Because I'm pretty sure we did this earlier. No, that's the sprites, color graphics, advanced basic. How to use variables, line numbers. Alright. So advanced basic, I think R&D, I think it's just basic straight up R&D. Try and remember. So here we go, R&D. So random building function. One function final is random non-function. What design again? Often need random number function. See how rand works. For x to that 1. So okay. Okay. All right. So let's say we want a random color every time we go through. So let's do this. I can't put you down on the next line, can I? God damn it. So I need me to put this book somewhere. Hold on. So I can still see it. Alright. So for colour, I want to do excuse me. So I needed to go integer or int 6 times it by R&D 1. Whoops. I got to remember that I don't have to hold down shift. R&D from there, so it's going to give me a value between 1 and 6. I don't want 1 and 6. I want 1 and 16. Ah, god damn it. Let's do this again. So 16 times by the random number 1. And I'm doing it this way because R&D random produces floating point numbers. You can't put floating point numbers into screen space or color space. It doesn't work that way. Excuse me. It doesn't work that way. So now let's finish writing what I was doing. Okay, so we're going to do, could we do some random characters maybe? That's a big number to do. But let's do it. Let's see what we can do. So I need to find that appendix. Ah, here we go. Is it? Is that it? Indeed it is. So 127 is what we need to do. Between 0 and 1. Between 0 and 127 is what we need to do. So we're going to do a random character from there. So what we need another poke. So we're going to poke our value into memory. So poke L minus 54272 10. No, hang on. No, you screwed it. Int 127 times it by RND 1. Now that should give us a random character on every single random color on every press of the button. So let's see what we get. A list. Let's get rid of all this. Oops. Just go to list just to make sure. Okay, that looks pretty close to me. What do you reckon? Shall we do it? Yeah, let's do it. Let's do it. Run. So we've got an E. Now we've got an underscore. Now we've got a column. That is cool. That is fun. That is amazing. Woo. So that's how fun coding can be. If you just don't blindly follow the listings, once you've got a running, say, okay, how can I break it? I've got this running now. Can I please break it? And look at this. Look. That is amazing. That is really cool. One thing we could possibly do is do some more if statements. But I don't want to. Because I am running on 33 minutes right now according to OBS. And that should be enough for now. The next listing in this, next program, is called SPR input. Essentially, this program will allow you to enter data for a sprite of your own and will poke the sprite data into memory and display the final product on the screen. This is very helpful for when you are trying to perfect the sprite and don't want to go through the tedium of making a subroutine to poke your sprite data into the computer's memory and display the sprite on screen. So basically, it's just a program to ask you a series of questions, like what data, what's the number for this column, this column, this row, this column, this row, this column, this row. So, like I did when I did my sprites video, which seems to be very popular for some reason. I don't know. Anyway, so where is it? Where's this thing? Okay, all right, there I am. So hopefully you've all learnt something today. I've got some more coding programs here. So if you do want me to go on with this, please let me know in the comments below and I'll do some more. Please, once again, please go out and do some more yourself. If you do this stuff, make your own changes. See if you can get your programs. Share them with me. Share them on social media. Do what you want. Because programming is no fun if you don't share it. Programming's no fun if you can't show it off, so to speak. And yeah, and I'd love to see if you're actually learning anything from these, because I'm not sure if you are, truth be told. But anyway, till next time, admire the lovely SID chip. Always worship the SID chip, and I'll see you all next time. Bye bye.